Okay, example 3. The equation shows a circle, right? A circle, clear cut, because this is obviously a circle. Center 0, 0, radius 1. So this is quite obvious. 1, 1, minus 1, minus 1. By considering something, show this. Now, first of all, we must realize that actually we have no idea how to integrate square root 1 minus x squared. We do not know how to integrate by hand, at least. You ask me to give 3SF, I will be able to give you because I have limits. I just enter into GC, but we don't know how to integrate by hand. So integrating by hand to show this result is out. We can't unless are given some help. So now we cannot integrate by hand. We still want to show this result. And actually integrating square root 1 minus x squared, you realize that by rearranging this expression, actually square root 1 minus x squared is actually y. And to be more specific, the positive square root 1 minus x squared is actually this portion here. So by integrating from 0 to 1, this portion, it's just this area that we're talking about, right? Yes? So may we just write down integrate from 0 to 1, yes, is actually equal to this area over here, which is actually area of circle divided by 4. Yes? Area of circle divided by 4. Alright. And what is the area of circle? Area of circle is pi. Radius is 1 square divided by 4. Therefore, it is 1/4 pi. Now, can I just emphasize that this step is crucial? Because the answer is given. You better make sure that you show the examiner that you understand this thing. It is the area of the circle divided by 4. Important. Can? Alright, let's go to the next part. The diagram shows, given diagram, diagram shows this, which is here, the diagram. It shows a circle. Center is 1, 0. Okay, no problem. Center, this is the circle. Region R is bounded by the circle, the x-axis, and the line x goes to 1. Let's look carefully. Circle. One more time. Region R is circle, x-axis, and x goes to 1. So clear cut, the region is here. Alright. Show that the volume of the solid form when R is rotated 360 degrees about the x-axis can be expressed as this. Show. So again, because it's a show question, the working here and the presentation must be detailed enough. Alright. Now let's take a look here. First is a volume. Yep. We want to recall volume is, and is rotated by x-axis. So recall that is V volume is integrate pi y square dx. So we want to find what is y. Now for the equation of the circle here, we need to get this y square out, or maybe first make y the subject of the formula. So that's our first job here. Make y the subject of the formula from here. We are going to make y the subject. Correct? Because we eventually want here. Correct? So, how do we make y the subject? Not difficult. Bring the x square over the other side and then take square root. Let us not forget the plus minus square root. And we get here 1 plus minus square root. Now, why is there a plus minus? It's quite obvious, because for one particular value of x, let's look here, if I say x is minus 0.5, you actually get two values of y. So you look here, one value of x, you will get two values of y because of the plus minus. So now we have to be very careful which is it that we choose. Okay? Can we all see, is it quite obvious then that if it's a plus, then it's the higher, it's the larger values of y, then this is the top half of the circle. This is the bottom half with the 1 minus. This is the 1 plus. Yeah? So actually when we want to find r rotated about the x-axis, do we use the plus or the minus? By now I think it's quite clear. Yep. So the r is bounded by this, the curve, 1 minus. Yep. So volume generated, let us recall, it is volume is integrate pi. This one no need to copy, not even in the working actually, but I just want to remind ourselves this formula. Then you get integrate from 0 to 1 pi y square dx. Okay. Answer given. So we take care in expanding. You have a minus b square. We make use of our formula. Not formula. Alright. Get a square minus 2ab plus b square. So, sorry, let us not forget the brackets. Right? Yes. Correct. Again, this is a square minus 2ab plus b square. Correct? And then you have clearly shown this. Yep. Is that what they want us to show? Yes. Let me see. Sure. Okay, next part. And then now you want to find this volume. Find this volume, giving your answer in exact form. Contrast it with the earlier example. This time, exact form cannot use GC. You can use GC check answer, but you can't use your GC to evaluate. So you are required to find the exact form. So how do we evaluate this in exact form? What we are required is to integrate term by term. Look carefully. This term, this term. Now, actually, integrating this one, 2 minus x squared is not an issue. So let us do this. Let me try and do this. I factor, pi is obviously out. Integrate 2, I get 2x. Integrate x squared, I get x cubed. With 3. With limits 0 to 1. I tackle this one first. Can? Okay, I tackle this one first. Now the other part of it is this one. Correct? This one. Okay, offhand I don't know how to integrate. Never mind, I write down. Minus a 2 pi. Integrate from 0 to 1. Square root 1 minus x squared. Offhand I don't know how to integrate, but never mind, let's work this out. This one easy. Already done now. We already integrated quite easy, just substitute limits, we are done. Now we have to worry about this one. Do we know how to integrate this by hand? We actually don't know. But as part of the question, you realize in earlier part here, you have shown this. Do we all remember we have shown this? Even if you don't know how to show it, can you please make use of the result? Follow? So, we can make use of this result. Substitute in 1, you get 2 minus 1/3. Sub 0, you get nothing. Minus 2 pi. Now, this result is powerful from earlier part. Yes? Therefore, you get pi exact form. We can use our GC to check this answer. Yes, but we can't use the GC to find an exact form. Alright?